Hello, everyone. I'm Yuexi Chen, a PhD student from University of Maryland. Today, I'm going to present our paper, TutoAI, a cross-domain framework for AI-assisted mixed media tutorial creation on physical tasks. It's a collaborative work between University of Maryland and Adobe Research. How-to videos are one of the most popular categories on video websites like YouTube. People learn life skills and solve problems by watching how-to videos. For example, making pancakes, applying makeup, and repairing a car. But there are pain points of navigating how-to videos, since the video does not provide an overview and the information in a video is not browsable. You just need to scrub the timeline to seek information, which is imprecise and tedious. Mixed media tutorials, which combines text, images, and videos, have a superior user experience. Mixed media tutorials have diverse formats. For example, concept maps for lecture videos and ingredient lists for cooking videos. However, it's tedious to create mixed media tutorials manually, and auto-generated results are of low quality. One of the most common mixed media tutorial is YouTube chapters. Here is a YouTube chapter automatically generated for video on how to make Seesaw for kids. It has 5 chapters. Each has a timestamp and text description. Users can jump to different parts of the video by clicking those chapters. But the quality is not guaranteed. In our interview, the creator of the video told us that the text descriptions did not make sense. For example, DIY Seesaw. DIY Seesaw is the title of the entire video, not a step. Researchers have developed methods to create high-quality mixed media tutorials, but such methods rely on domain-specific knowledge and may not be available to other domains. For example, makeup tutorials rely on facial parts like eyes and lips to cluster steps. Recently, we see advances of AI, especially foundation models that could be adapted to a wide range of tasks. We believe there are opportunities to generate mixed media tutorials without domain-specific information. But there are several challenges. Converting the input video into a mixed media tutorial involves multi-modal information, and multiple models are required and applicable. Another challenge is that models could also make errors, so there are 2 research questions. One is how to select models to create mixed media tutorials. The other is how to design user interfaces to refine AI-generated results. We propose TutoAI, a cross-domain framework for AI-assisted tutorial creation. First, we surveyed existing mixed media tutorials from 10 research papers and 3 websites and distilled common tutorial components, including steps, objects, and dependencies. For each tutorial component, we identify applicable machine learning models and assemble them into different pipelines. Then we evaluate the pipelines and extract the components. Finally, we build a user interface for tutorial creators to refine the AI-generated results. Let's look at an example of how to extract objects from how-to videos. Here is a cooking video on compiled chicken. An important ingredient is chicken breast. It's mentioned in the transcript and also appears in video frames. But how can we extract the object information automatically? One approach is to employ an object detector. Given an image, it will draw a bounding box and return a text label. However, general object detectors are only trained on common objects. Less common objects like chicken breast are out of its vocabulary. As a result, it only recognizes dining table and ball in this image. Since we have transcripts, another approach is to use part-of-speech tagging. Part-of-speech tagging will assign a word to a grammatical category, like verb, noun, and adjective. Here are the results. For this paragraph, it returns 3 nouns, ingredients, chicken, and breast. Not what we want. A third pipeline is to use large language model prompting to extract object names. And it can even return adjectives like bonus and skinless. But we only have the object names. How can we extract the image? This leads us to open vocabulary object detectors. By projecting both image and text embeddings in the same space, it can recognize out of the vocabulary objects as long as there is a text label. Here is an example. We provide object labels extracted by large language models and use it to guide open vocabulary detectors. It can successfully identify rare objects like chicken breast and chopped green pepper. Besides objects, we also constructed machine learning pipelines to extract steps. Finally, to decide which pipeline to choose, we evaluate them on a large-scale cooking dataset and a small but diverse instructional video datasets. Besides objective metrics like F1 scores, we also consider the correction efforts required by humans. Although our machine learning pipeline has achieved great performance, it's not perfect, so we also built a user interface. We followed several human AI interaction guidelines proposed by Salima et al., like supporting efficient dismissal and correction. Here is our UI. There are 5 stages to create a mixed media tutorial. Currently, we're at the first stage, identify steps. On the left is a video player and the transcripts with timestamps. On the right are steps extracted by TutoAI from the video. Each step has a start and end timestamp and text descriptions. We can add new steps and revise text. For example, currently we split measuring and marking the board into 2 steps. To revise the timestamp, we find it in the video and then snap to the start. The second stage is to choose thumbnails. For each step, TutoAI recommends video frames, and users can drag the slider to show less or more, and pick one. The next stage is to associate objects with steps. TutoAI has already associated some objects with each step, and we can add new ones or delete objects. The next stage is to crop objects for images. TutoAI has suggested objects areas in the image, and we can adjust the bounding boxes manually. The final stage is to build dependencies. Again, TutoAI automatically infers dependencies between steps. And to build new dependencies or delete dependencies, we just need to drag and drop the arrows. Here is the final version. On the left, we have the video player and objects in the video. Hovering on those buttons, we will see images. On the right is the dependency diagram. It shows an overview of the video content, and we can click on those steps to jump to the segment of the video. We conducted preliminary user studies by recruiting 12 participants who regularly watch instructional videos and asked them to rate components quality returned by TutoAI and YouTube chapters. And TutoAI has achieved better results in both before and after editing. We also recruited YouTubers to try our tool, and they spoke highly of it, especially the flowcharts. They said viewers would get more compared to regular YouTube chapters. From the perspective of human-centered AI system builders, we find existing guidelines are not enough, so we also introduced new guidelines. Initially, we suggest system builders adopt a multi-modal perspective to survey the model space more thoroughly. During interaction, if the system supports complex creation, then we should guide users in the process and even constrain users' actions. We should also separate content from styles. Though mixed media tutorials are of diverse formats, as long as we have components like objects, steps, and dependencies, we can easily apply other styles later. When models went wrong, it's important to select models that are easier for users to correct. For example, false positives are easy to delete, but false negatives require users to manually go over the video and find the object, which requires more efforts. If models do not work, then the UI should support graceful degradation. Finally, in the future, the landscape of machine learning models may change, and it's important to keep track of the state of the art and use it to guide the models in other modalities so that we can minimize compound errors. TutoAI also has limitations. It's designed for how-to videos on physical tasks. If we plot how-to videos in the coordinates of number of objects and actions, then it works better for videos with more objects, as we rely on object information to build dependencies. In the future, we expect there are other methods to build dependencies automatically for videos with few objects, even just for abstract concepts. Finally, I'd like to thank my advisor, Professor Zhicheng, and our collaborators at Adobe Research, Vlad and Truong. Thanks, everyone.